Okay, in Chapter 7, we started out graphing rational functions, and that's where we're getting back to in 7.8, which is the next lesson. We'll get into that. But in today's lesson, what they're trying to do is to get us, again, ready to break down expressions into small parts and look at things that cancel out, because all those things are going to help us graph those rational functions. And they're going to teach us a little bit about it, in the next section more, but they're trying to get us ready for that. There's one example out there of a very, number 61 at the end. There's another video, but there's not anything closer in, so I thought we would do something. I'm going to just pick number 17, because I see some things about it that I noticed, people might have trouble with. So the idea here is when we multiply things, we can just kind of shove it all together, and what we're going to see here is there's going to be things when we multiply that a lot of times will cancel out or reduce, and sometimes maybe it's not as obvious, so this is why I picked this one. Okay, so, I could shove all this together. If I'm going to do that, I need to kind of do this. I need to put parentheses around it because, otherwise you're going to have a mess and you're not going to be able to tell what goes where. All these things are multiplied. Now, if you look, there's something right off the bat that I can do. I see 3 plus x. The commutative property tells me I can rewrite that as x plus 3. So let me rewrite it first. And then notice that if I do that, I can cancel this factor out with this one. You think about, what if you multiplied a half times 2/3? Wouldn't the 2's cancel out? That's what we're doing here. We have factors. They just look a little bit more complicated than the ones maybe I wrote over here at the side. We were used to doing that with fractions back even in elementary school. And this is what our fractions look like now in high school. Now, remember, when things cancel out like that, when I go to graph in the next section, those are going to be holes. I would have a hole at x plus 3 equals 0. X is negative 3. We're not having to write that here. We're just simplifying. We're still working on factoring and simplifying. So let's look and see if we, I could write a 1 there and a 1 there because x plus 3 goes into x plus 3 one time on each space. All right, so let's go and look now at everything else, because if I factor things, most of the time a lot's going to cancel out here. That's the whole point, is they really want a lot to cancel out here. So let's look at this x squared minus 3x minus 4 on the top of my fraction here. I'll write it all after we kind of figure out the factors. I'll write them all in here. I'm just going to look up at the line I already have written. I'm thinking, what can I multiply to get negative 4? And at the same time, the two numbers have to add up to negative 3. And again, you don't have to use this little diagram. It's just for those of us who need a little help. Well, I know that to get 4, it could be 2 and 2, but that's not going to add up to 3. I know 4 and 1 have a difference of 3. If I made that negative 4 and 1, positive 1, they would multiply to give me negative 4 and add to give me negative 3. So if you remember what we did with those is I'm going to replace this expression here with its factored parts. And remember, I put an x here and an x here. Each factor gets an x, and it's x minus 4 and x plus 1. So I factored that. Now I'm going to look at this bottom part right here, this 16 minus x squared. I'm just going to come off to the side to work with it. I notice there's two terms. There's no GCF to pull out. And so I'm thinking, are these perfect squares? Because when there's two terms, a lot of times that's what's going on. And yes, I can rewrite them as 4 squared minus x squared. So if you remember how you factor that, this 4 would go here and here, and this x would go here and here, and you need 1 plus and 1 minus. Now, okay, so let me write that down. That would be 4. Remember, all this is on the bottom now because I could squish it all together when I multiply and put it under one fraction bar. So it's 4 plus x over 4 minus x. All right, you might look and think there's nothing to cancel out here, but there really is. And this is what makes this one a little tricky here. When I see 4 minus x, I notice it looks an awful lot like the thing up here. It's just a little bit different. We've had this show up several times this year in different places, and what we've done, we said, well, you know what? On this 4 minus x, what I can do is I can factor a negative 1 out of it, and that would become negative 4 plus x. And negative 4 plus x is the same thing as x minus 4. So that's what I'm going to do. I'm going to take this term right here. Let me just rewrite what I have so far. I have x minus 4 on top. I have x plus 1. You know what? 4 plus x is the same thing as x plus 4. The commutative property says at least when you're adding, it's easy to switch them. It's this subtraction one I'm dealing with that's a little harder. And then the 4 minus x, I'm going to factor out a negative 1 out of it, and I'm going to write it as x minus 4. And again, why I did that is all off here to the side. How I got that to happen is off here to the side. Now that I do that, I can say, oh, yay, something cancels out. The x minus 4's cancel out. So on the top, what I have is x plus 1. And on the bottom, I have x plus 4 times a negative 1. We usually put the negative out front, and a lot of times lazy math guys are going to leave the 1 off of it and just write the negative. I'll write it for now. So I have something like this, usually what you'd see written in the answer key. I keep up with all the parentheses, as I go, and so even in my answer, I would have put my parentheses around the x plus 1. The answer book might leave it off, the x plus 1. I'm going to look and see real quickly. Okay, they write something weird. They mess around with it. I would not worry about messing around with it the way they do. They write, and it's the same thing, they write the negative out front equal with the fraction bar. Remember, I can put the negative on the bottom, on the top, or equal with the fraction bar, so they just choose to do that. They write their x plus 1 on top, and then, I switched 4 plus x to x plus 4. They left it like 4 plus x, which is fine. You can do whatever you want to do. Either one of these on the bottom, any 3 of the ones written in black would be correct answers, okay? I don't know that I would have, thought to write the negative out front equal with the fraction bar like they did. But again, as long as it's an equal expression and it's reduced, you're going to get credit for it. Okay, I was looking for one that was division, and I started to pick another one. I need to do a division one on here just in case anybody's watching it and needs to see how to do division. If you remember when you had a fraction and you were dividing when you were in elementary school, junior high, let's say let me write the problem down first. We're dividing by x squared minus 16 over x squared plus x minus 2. Okay, let me come off to the side and let's just remember how to do division with fractions. I'll just do it in a different color. If I had a half divided by 3 halves, I kept the first fraction, I changed the division to multiplication, and then I flipped my second fraction. So it would turn into a half times 2/3, and then you could start seeing that you could reduce some stuff, right? So that's what's going to happen here is a lot of people call this keep it, so keep the numerator, change the division to multiplication, and then flip the second fraction, okay? So that's how some people remember this really quickly. It's just to kind of keep it, change it, flip it. Easy to say, helps people remember. All right, so what I'm going to do is I'm going to keep my first fraction. In a minute I'll go factor this, but I'm just going to write it down like we want to look at it. I'm going to change the division to multiplication, and then I'm going to flip my second fraction. Okay, so now I've gone ahead and taken care of turning the division into multiplication. Now what I got to do is, just go ahead and factor. I'm trying to write an equal sign in there. Okay, here goes my equal here. So now, on the top, let's write little parentheses because we kind of think maybe everything will factor. We're not sure. If it doesn't, then I'll tell you what, we'll start with the first fraction. What multiplies to give me 12 and adds to give me negative 7? Oh, negative 3 times negative 4. 2 negatives make a positive, and they add to negative 7. So this top one up here, this x squared minus 7x plus 12, on the first fraction is going to factor into x minus 3, x minus 4. I'll kind of color code a little bit. On the bottom, this one right here, I'm thinking what multiplies to give me negative 6 and adds to give me negative 1. Let's see, 2 and 3 are 1 apart. Maybe they'll work. If I make 2 times negative 3, that's a negative 6. 2 plus negative 3 is a negative 1. So I could factor that bottom into x plus 2, x minus 3. Already some things are canceling out. Let me just go ahead and mark them out since I see them. Look at this. This x minus 3 and this x minus 3 are going away. All right, let's go to the second fraction. I'm thinking, okay, I'm looking at the top, so let me circle it in maybe green so you can see where I'm working. I'm thinking, what multiplies to give me negative 2 and adds to give me a positive 1? Well, I know 2 and 1 have a difference of 1, so they're probably going to work. If I want a positive 1, 2 minus 1 is 1, and 2 times negative 1 is negative 2. So that green one factors into x plus 2, x minus 1. Do you see why we have to be able to factor pretty quickly? If not, yeah, you're going to spend forever on this section, but guys, you should be factoring a little quicker by now. You did it in Algebra 1. We even did it last year in geometry and reviewed it, and now you need to be pretty competent at it. If this is taking you a long time, I'm sorry, but you've got to get faster at it. That's just part of the deal. You got to remember what you learn from year to year. And if you don't, it's going to hurt, okay? And unfortunately, we're at that stage. All right, now the x squared minus 16 here, that's a difference of two squares. Let me circle it in blue. And remember, the difference of two squares, can I rewrite that as two squares? Okay, I'm going to come down here into my little list on the left here where I'm working. I can rewrite that as x squared minus 4 squared. And so that factors into x minus 4, x plus 4. X minus 4, x plus 4. I could have said x plus 4, x minus 4. Doesn't matter what order I write it. So now, this was a minus over here. I'm looking for things that cancel out. And I'll use a yellow marker here. Ooh, these x plus 4s cancel out, right? Let me pick a different color. Let me pick a green. Look at this. The x plus 2s cancel out. What I have left on 23, all I have left on the top is x minus 1. And on the bottom, I have x plus 4. I could still put them in parentheses if I want to, but I'm pretty sure the answer key in this book's not going to do that. No, they don't. They just write it just like this. Again, putting the parentheses is not wrong. I think writing the parentheses in as you work is a necessity. You got to do it so you can see the things that go together, that are factors. Otherwise, your eye just can't distinguish between where one thing stops and another begins. And I even write them in my answer, so it doesn't matter whether you do or not, but the book doesn't.